recorded. So this is a main screen, right? Now, by the way, if you have any questions, just you can interrupt me and ask. I'll explain. So this is main screen. So left part. The left part is this panel is layers panel. Right panel is actually you can open using this button, this object properties panel. So I'll explain it a little bit later. So all layers that will be created while within the session or while working, so they will appear here in this layer. So you can shift between different panels just by clicking these buttons. So this one is currently we are in layers panel, and this one will switch to sections panel. And here this is chat. So you can write if you have any questions. Yeah, you can just write directly here. So anyone who is who get access, so they will see your message. So this one is navigation bar properties. This is the properties of the created layer. Now this is the main screen, main scene, right? So this main scene, before working, you need to somehow set up your toolbars. These are toolbars that are available. Now I'll set them as appropriate for me. You can configure it as suitable for you later. So first of all, okay, let's rearrange all this toolbar. So there's some toolbars currently we don't need. I'll just put them here. Several toolbars for this session. We will not use it. So other toolbars, we need all these toolbars. Now just by clicking this button, right, this button, it will open, collapse it, and you can just configure it by repeating the clicking. So I'll put it here. So this is a common this toolbar contains common tools. So common tool just hide or show the objects they are what is in the scene, and these are the for showing and hiding grids. So these are mesh tools. These are for or automatic or body creating. So currently we won't use it. So what we will need, so we will need this polyline tools. We will need mesh tools. We will need this interactive edit tools. We will need yeah, this primitive geometry shapes. Then we'll need some these tools, so we'll arrange them as suitable for us. So I think everything is clear, right? We prepared toolbars, so they are now currently allocated along these lines. Now we start working. from the beginning, I think we need to start. We need to learn how to open some files in Dolon.pro, right? In this our tool. So in order to we Dolon can open can import data from different formats. So if you are geologists, I think you have already worked with Micromine, and I think you have already have some files in Micromine format, or have some files in CSV format or DXF format, or some TXT files that contains points or different data, right? So in order to open the in order to import data from files, so you can use this button and load file, import data from, let's say, from CSV file. If you have CSV file that contains points, right? Maybe you have already prepared some files for different purpose. So you can open using this tool. Okay, this one, Topo CSV, it contains points, point cloud for DTM. So and it was saved in CSV format. So we will indicate that this is a point. Once you open, you see all fields that are in the file, so they will appear here. So if file contains some fields that have the name East, North, RL, or XYZ, those fields will be automatically mapped here. So if you use Micromine, I think you are already familiar with this type of approach. Just for information, I will show you this file that we are currently opening. So we are currently opening this Topo CSV file, and this Topo CSV file is this is the content of Topo CSV file. So this is just ordinary CSV file. These are the fields, and these are the values. So now we are opening this file, and while we're opening, so it will indicate that it's a points, and map x, y, z coordinates are already mapped, and we'll open. So it opened, it imported points as a cloud, as a point cloud. So this is how we can load data from CSV file. Okay, let's open another file. If you have DXF files, I mean the AutoCAD files, so you can open AutoCAD files also. While opening AutoCAD files, so you will choose here all the layers that have in AutoCAD file. So here you can see that when we open the files, the appropriate layers was created here. So for points, created points layer. For the time being, we'll just make it invisible. And for the DXF file, it opened here, and all the layers are opened also here. So now we will show it all. So this is a DXF file. So we imported a lot of data from DXF format. Now let's open Micromine 3DB file. So this is a 3DB file. the list of mesh wireframes in 3db file, so you can choose all. And yeah, we can make this layer invisible. So this is, we imported data from 3db file, so this is a Micromines format, right? This is a wireframe that was created in Micromine. Now we can open from the str file. str this is a Micromine string file. So I have here some strings. Okay, this is a string file. Okay, this is a string file, and let's okay. It didn't open it. Maybe missing some data there. For this, okay, open. Let's open this str file. So these are mapped already. Close. Let's try this once more. Yeah, here's North China. Yeah, something has broken for the Micromines format. Okay, so we need to check it. Besides string file, we can open dot file also. So this Micromines, if you have dot file, okay, let's open any dot file. So this is a dot file. We can open it as a point, right? So this is Micromines dot file format. Yeah, and we opened it as a point cloud. So the first thing, we can open files from different formats. So basically there are text files, CSV files, DXF files, Micromines 3db file, str file, and dot file, and also also PLI file. If you have PLI format, we can import data from PLI format also. So this is for importing data from different file formats. Now we can clean up the SAN and start working with our tools. So first of all, let's start using this polyline tools. So basically it's I think most of the geologists or most of the users, they already use some kind of 3D modeling tools, and they they know how to use polyline tools, right? So if you already worked with Serpac, with Micromine or other Leapfrog, so they have the similar tools. So we'll start now using polyline tools. First of all, this one is for creating polyline. And you can, once the polyline is created, so you can modify it. And these tools are used to work with polylines. So once polyline is created, so we can, if you need, add some points here, right? So we can activate insert point mode. So for this, we need to select the desired polyline. If you have, let's say, two different polylines, two separate polylines, yeah, and we need to add some points here in this into this polyline. So we select this polyline, then activate the insert point mode, and we can put points here. So if you need add some points here or delete some points from this, first we select the polyline, then by clicking Control and keeping Control button, we will just hover over the point, and you can see this symbol, right? So the cursor is changing. Once it's changed, so you can just click it and it will be, the point will be deleted. Now, okay, we'll insert some points. So on the right panel will be shown properties of the selected object. So this one, or we can select this one, and these are properties of polylines. So once polyline is selected, we can show points labels. So this are point labels. So okay, this point labels, or we can show points, show pivot point. So pivot point means this one, this dot circle, green circle, green dot, is a pivot point of this object. Why the pivot point is needed? So okay, I'll explain it, I think, a little bit later. So showing pivot point means once it's ticked, so pivot point will stay visible. Let's say for this, now when we are deselect, the pivot point is disappearing. If we show pivot point, so it stays visible. Not snappable. It makes this object not snappable. Not snappable means if we start to create another polyline, we can activate here snap mode. So snap mode, let's say snap to lines, right? And when we create these lines, they are snappable. So if we make this object not snappable, and if we start extending polyline, now you see this object no more snappable. So we can snap to this object, but this one is not, because we made it not snappable. So, and this depth test, yeah, that's a little bit later. I think I will explain it a little bit later. And reverse point orders, it will reverse point orders. Currently, you see the point orders is like this: 1, 2, 3, 4, 5, 6, and etc. So once we click it, so it will reverse the point order. Reverse it back, it will reverse point order. Now, so further, split polyline by deleting a segment. So this instrument, this button, splits polyline by deleting some segments. Let's split it. Yeah, okay. So we split it. Now further, if we delete, okay, if we click this segment, so it deletes this segment. Now appear two different polylines, and we can delete this segment. Yeah, this part has remained separate. So this tool will split polyline by deleting the segment. And there is another tool. This one splits polyline by on some point. So okay, let's pick any point here. Oh, okay, maybe we made it. Not snappable, right? No, made it snappable. Okay, it's now snappable. Split polyline. Okay, yeah. Seems also something here broken. Let's check it. Yeah, this button is supposed to just split on some certain point. So later project on the reference plane, I'll explain a little bit later when we reach to reference planes, and this mirroring polylines. So mirroring, that means we can select any polyline, and just by clicking 2 points, it will mirror selected polyline, so according to the line. So it will create copy of the mirrored copy of the polyline. Okay. Okay, going further. So project polyline horizontally. It projects polyline horizontally. That means you can set some offset to vertical offset. So let's leave it as is, 1, no, 0. 1 is, this is the amount of copy. So let's say 2 copies. And you can see, right? So this is 2 copies of the projected expanded polylines, and you can see here some intersected segments. While projecting, there is an option, remove intersections. Previously I unticked this one. So once more, just try once more and tick it, this one. So in this case, so it will automatically remove this kind of intersections. Sometimes it's needed to leave the intersections as is. sometimes you don't need them, so you can just put the here option remove intersections. So this is for projecting polylines horizontally. And this one is simplifying polyline. So before simplifying, let's smooth the polyline. Smoothing polyline, there is some options here, and we need to this option, put the options. That means we need to set the angle in degrees and proximity factor. Let's leave it as is. Number of points in smoothing curve, so we can control how many points needs to be created. So we can put 15 points, and depending on the segment length, it will automatically create the points up to 15 points for each segment. So this is a smoothing the polyline. Further, so this now simplifying polyline. So if polyline, there are some points, dense segments. If we want to simplify, we can use this button and removal factor. So leave it as is, and minimum removal angle. It depends on it will set the what type of curve this here, right? So it needs to be simplified. So by default it's 160 degree, and you can put you can control it. Made it more, and you can delete more points. So we simplified it. So this is features, tools that are needed for to work with polylines, and we haven't tried yet this projection onto reference plane, and project on XY plane, and project on surface. So we will do it a little bit later. So let's now explain what is reference plane. So far, do you have any questions so far? Hello, guys.
Yes, I'm with you, Mr. Sabir. It's going very well.
Okay, if you have any questions, you can interrupt and ask if anything is not clear, right?
Okay, got it.
So now, so far, we've created all these polylines on XY plane, right here, and XY plane we can navigate using this navigator and show the grid, YZ grid, and that was on the 0 level. And if we want to draw some lines, not on the drawer, on some that elevation, right? So we can that elevation make constant. So we can we can toggle that plane. So in order to toggle that plane or make some elevation constant, we can use this toggle reference plane. So in order to set the elevation, we will just click this button. Then we can use, let's say, on this level, right? 50. That's coordinate is currently this 50. Yeah, we can activate this dynamic mode. Okay, we will activate this dynamic mode, and this is a elevation. Okay, the elevation, and next there will be also some point with the elevation 50. Yeah, and we created one segment, and just by clicking right button we toggled reference plane. So this one is shows and hides reference plane. This is just for orientation. So this shows where is reference plane and how is oriented, right? Now once we toggled reference plane, any further changes will be projected onto reference plane. Let's say let's start creating another polyline. So in order to, let's maybe you haven't noticed that I just created and closed polyline. In order to close polyline, once you created this polyline, right, and in order to make it closed, you can just push on the keyboard key C, close. So if you just push it, the system will automatically close. And if you want to open it, just click on key O, and it will open it. Okay, so for the time being I will just close it. Yeah, now you can see, right? So any change, anything that I've created now, it's created on the reference plane, on that plane. So this one is just for orientation. You can create anywhere here or somewhere else. Anyway, it will lie, it will be project on the reference plane's level. So this is one way of creating reference, toggling reference plane. The reference plane can be created using 2 points, as I just shown. In this case, it will be created perpendicular to the screen, or reference plane can be created using 3 points, or if you just don't want to use reference plane, once the reference plane is set, it's already set. Now you need to unpin it. In order to unpin it, this one, dynamic reference plane, makes it dynamic. Dynamic means as I saw the screen, any change will be automatically adjusted to the screen's plane. So let's say, yeah, currently I'm looking at the screen in this from this records, right? So it will automatically adjust the plane to the camera view, how I look at the screen. And if I look from this view and I start to create something, so it will automatically adjust to this view. You see, right? And if you need some certain plane in order to work, so you can use this toggling reference plane by combining the snapping to points and using 3 points. Let's say this 3 points. You can create reference plane. So Once reference plane is created, now any change will be created on that reference plane. Now this tool, so this project on reference plane, so it will automatically project the object polyline onto this reference plane. It will not rotate, it will just project. So you need to understand this. So this one currently, yeah, this is a polyline, and this is a reference plane. We will project this polyline onto this reference plane. So once polyline is selected, we'll just click on this button and it will project onto this reference plane, right? You can see. So this is not the rotation, it will just project it. For the time being, I'll undo it. And if you want to rotate it, you need to use a little bit different tool. So for this purpose, yeah, you can use these tools. So these tools are for translating, for moving objects to different place. So this is rotation. So in order to rotate different objects, you can use this tool. And this one is to scaling objects. So let's use rotation tool. Okay, we'll select this polyline and activate rotation mode. And here appears gizmo, and using this gizmo, you can rotate objects. Yeah, these are the along axis, y-axis. This green, this is along y-axis. Red is along x-axis, and blue is along z-axis, around this z-axis. And there is another extra this circle. This will rotate around the axis that is in view direction. How we look at the sun, so it will rotate around this axis. Now, pivot point. Previously, I've told about pivot point, right? So this is a pivot point of the object. Pivot point, it is used mostly in order to make rotation or scaling properly as you want. You can set this pivot point in some place, and rotation will be carried out in terms of this pivot point. Let's say put this pivot point to this place, right? So in order to change the pivot point in polylines, you select polyline, then keep key shift, press it, and just click anywhere. Yeah, and the pivot point will be set to those places. If you want to set the pivot point along this axis, you need to activate snap mode. Currently, I will just put it yeah, here. And you can see, right, so it will be automatically projected to the reference plane because I have toggled reference plane. If I untoggle the reference plane, so this pivot point will be set on this polylines plane. Okay, let's just demonstrate it. I've already put here this put on this reference plane. Now I'll start to rotate, and rotation is now is done according to this pivot point, right? So object is rotated around this pivot point. If I untoggle the reference plane or make it dynamic, then pivot point will be set on the polylines plane. So polylines plane, it will automatically, when we select any polyline, automatically will be calculated plane of the selected polyline. You can see, right? So now we set pivot point here and rotate, and rotation will be carried out along this pivot point. While rotation, you can set pivot point just also by keeping shift key, press it, and I'll click this or to these points or somewhere else. So this gizmo will be placed here, and rotation will be done according to this gizmo's pivot point. This one is object's pivot point, and gizmo has its own pivot point. Now this is a rotation tool. This one is scale tool. Scaling tool, that means you can scale object, make it bigger or make it smaller. So this also scaling tool also done according to pivot point. So if pivot point is here and we start to shrinking it, so it will be shrinked. Here you can see, right? According to this pivot point. If we set pivot point here, so shrinking also will be done according to this pivot point. So why pivot point is so important? Because it will directly affect to the rotation and to the scaling of the object. So far is everything is clear? I guess everything is clear, right? Okay. Now let's go further. So we've almost completed all these tools related to polylines. Now switch to these geometrical shapes. They are also kind of polylines, but they are the predefined objects. So if you need to create some circle, so you can use these tools and put here some point, then radius, so it will create automatically a circle. And so it will be created. You just need to remember that it will be created if you didn't toggle reference plane. It will create it automatically by adjusting the camera's plane, I mean the screen's plane. If you look at this from this point, from this view, so camera will automatically adjust this plane and everything will be created in this plane, on this plane. Okay, this one is rectangle. And if you need to create them on a certain plane, on a certain surface, you need to toggle the difference plane and create all these shapes also will be created on that reference plane. So this one is ellipse. Okay. Now, for these objects, circle, ellipse, and rectangle, if you see the properties, these are the polylines, just ordinary polylines. These are some objects, the predefined objects. So if you want to edit, so you can activate edit mode and just adjust the rectangle. And if you convert it to the polyline, you will not be able to edit it as a rectangle anymore, because you have already converted it to the polyline. Now it will act as a just ordinary polyline, not as a rectangle. Same thing with circle. So this is the circle, and editing, so it will edit just by setting some radius. And if you convert it to the polyline, so further you won't be able to edit it as a circle. So any editing will be just done just as a ordinary polyline. Just want to make it clear. Okay, so now this is dynamic inputs. Dynamic inputs, let's a little bit briefly explain what dynamic input is. When you create, okay, just make it invisible and create another polylines layer. So this is a different polylines layer, and any new polylines that will be created, it will be created within this layer. Sometimes we need to create the polylines or some shapes, predefined shapes, and we know the coordinates, and according to those coordinates we need to create some type of lines or some zigzags or other stuff. So in this case we can use this dynamic input. So first of all, dynamic input, it helps to set certain coordinates automatically. So currently, yeah, we are in plan view, and it automatically shows me Z elevation as minus 17.994, and I need to put it on, let's say, on that zeros level, right? So further it goes also on that level, so I will change this. So I've created on that level. Now I'll toggle, okay, this one way. This one is a polar coordinates. It helps to create, let's say, first point. Okay, first point will be this place, and we will just orient on the screen's horizontal or vertical lines, and we'll create, let's say, 50 meters from that point. Straight means 0 degree. Then 50 meters needs to go on the 45 degree, and 50 meters further minus 45 degree, and 50 meters straight down, and 100 meters backward. So if you need to create this, if you know a certain size or certain coordinates, we can use this dynamic mode to create this type of polylines or some objects. So this is a dynamic input. Now, once we created these polylines, we can copy these polylines or clone these polylines and move it. So in order to copy the polylines, we can use just keep Control key pressed, and when we hover over the selected polyline, will appear plus symbol. So that means copying this the object is available. Let's look it in this from this perspective, and keep Control pressed, hover over the polyline and click and just drag it. Yeah. And we created 4 more copies of the initial this polyline. Now we can just select all these polylines, unselect this one, and this is a translate mode. This tool that moves objects, and we can move these objects, all these objects together somewhere if we need to some other place. Yeah, we can just move them. And if we need to rotate all these objects together, we can use the rotation mode and rotate all these objects together. So this is all tools related to polylines and reference plane. So shall we continue, or do you have any questions? Or for the today it's enough? Maybe we'll continue tomorrow. What do you think?
Just one question. What's the difference between the polygon number 6 and polygon number 8 from the top to down?
This one and this one, right?
No, no, no. The polygon number in the side of the mirror of the screen.
Polygon number.
Number 6 from the top. 1, 2,
1, 2, 3.
3, 4, 5, 6. Between 6 and 8.
Okay.
7,
Okay, from
8, 8. ليس 7. أيوة. Between 6 and 8. What's the difference?
this one and this one, right?
أيوة. Yes, yes.
Okay. I'll explain. So this one, it projects polyline onto reference plane. Okay, let me demonstrate once more. So we will toggle reference plane. Currently this one is plane. This is just plane, right? Now we will toggle this reference plane, let's say this way. So I will just draw one line, right click and create it, toggle the reference plane. Now I will project this polyline onto this reference plane. So just select and you see, oh,
Okay.
okay, you understand, right?
Yes.
This also. So now this is for this one and
Yes.
this one, this mirroring polylines. So that means it will create mirrored copy of the polyline. Let's say, okay, let's try this polyline. This polyline and mirror. I will create some line and according to this line, it will create mirrored copy.
Okay, 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 okay.
Understand, right?
Yes, yes.
Okay, so just once more. First point, second point. Okay, you see, this is all done according to the reference plane because reference plane is toggled.
Okay, okay.
You can see, right? Yeah. If you unpin, untoggle, just make a difference dynamic. So while mirroring,
Has the same dynamic.
it will be, you see, now the reference plane was not toggled. So as you see, as you look at the screen, so it will orient to your screen if uh, reference plane is not toggled.
Okay.
Okay, clear?
Yeah, clear. Thanks.
Okay, thank you. So any questions? Any more questions? Okay. So let's continue then. Shall we continue?
Yes, yes.
Now we will switch to meshes, to wireframes now. How to create wireframes, right? So, okay. In order to create wireframes, we can use some polygons or point clouds. Let's start from point clouds. You see, we have the two layers. I just made them invisible. Show all, nothing is here on the screen. Let's open some point. This topo points dot file. I have this dot file. We'll open it as a point. So this is a points, right? This is DTM. DTM means digital terrain model points. From this point cloud, we will create a wireframe DTM. For this purpose, we'll just select these points, and here on this toolbar we have this button, surface from selected points. So we can just select some points, some path, and create from this path, or we can select all these points and create DTM from these points. So we created DTM, digital terrain model. That's a wireframe, right? Now, once we created a wireframe, there are several tools in order to work with wireframes. So these are for simplifying, for closing, for center line to solid, surface from selected polylines. So surface can be created from points or from polylines also. If you have polylines, you can create DTM from polylines also. So now we created wireframe from points, and let's clean up a mesh. Clean up, that means while creating this wireframe, maybe there was some very small triangles or some incorrectly connected points. So this tool will clean up mesh and validate. So we just validated. Now we can create some polylines. Yeah. And close it. So I've created polyline. Now I will project it onto this surface. So in order to project polyline onto the surface, we need to select polyline and surface and use this button. So it will open this form. So we need to select the direction along Z and OK. So this polyline was draped onto the surface, was projected onto the surface. Right? Now, so this is a polyline that was projected, and let's toggle reference plane here. And we will copy, you see, this projected polyline currently located in this layer. So from this layer we will make copy and put it onto this layer. This layer is empty currently. So we make this layer active, then select this polyline, just click right button and copy to active layer. So since this layer is active, so this selected polyline will be copied to this layer. So let's make this a layer invisible, and you can see this one, right? So this is a copy of this layer, this polyline. Once we selected this, now we will project it onto reference plane. So we will use this one. So one, we projected it. Now once there are a lot of points here, right? So a lot of points are actually they are not needed. So we need to get rid of them. In order to get rid of those points, we will use the simplify polylines. Simplifying polylines, so it will remove unneeded points. So now we have just several polylines. Once those polylines removed, those points are removed, so we can use this polygon in order to cut this digital terrain model, this DTM. Okay, make that dynamic reference plane, untoggle it. So we will make it in plan view and select the polyline, select the wireframe, and we have this button, this tool, so it cuts mesh by polyline. So it cuts the mesh by polyline. So you can see, right, result. So, and you need to know that it will cut it as you look at this object. So let's undo it. If I rotate object in this way and I look at this object in this perspective, from this perspective, so this polyline, this polygon will cut from this, from this view. So this area will be cut. Yeah, once it's cut, so you can just separate this part to another place. Yeah, this is already cut mesh, and once mesh is cut, so we make it valid. So we need to make it valid, so validate it. Okay. And if you need to cut some part from the edge, you can just create this kind of polyline. Select this polyline, select the wireframe mesh and just cut mesh by the polyline. So we can just slice it in this way. And when using this gizmo, this moving tool, these indicators, so this one will move this along that axis, this along y-axis, this along x-axis, and this along the y-xy plane, this along yz plane, and here this one along xz plane. So this is very convenient tool to work with objects when you need to move them from one place to another place. So this is DTM. Now let's triangulate some polygons. So this polygon, right? So this polygon, let's move it to this place. And we can just triangulate it. Triangulate it means from this polygon we can create wireframe mesh. So for this purpose, the polygon triangulation, this button. There is several options how to triangulate it. So minimum area for 3D polygons, so we will use this option. And yeah, here it's created, but you can see this because of the recurse, because of the perspective, so it's somehow transparent. You can from this panel you can control objects properties of the mesh. So this is a mesh color. This is vertex labels, so you can make it this labels color. This not snappable makes object not snappable, and show as wireframe. It will show this as a wireframe, not as a solid. Load image can be loaded any image and draped onto the surface. And add attribute. Add attribute for any objects. You can add some attributes. Attributes, that's some field, some value that's added for or added by user. So you can add some attribute. Let's say attribute this part 1 type of value text, any text. So it will appear here. It's useful if you want to somehow group some objects within one layer, some objects into one object. Yeah, you can add some attributes and filter objects using that attribute. Okay, this is for triangulating polygons. Now let's create some solid from polygons, from contours. I've created several contours. Select those contours, and from these contours I can create some surface, 3D surface. So for this purpose we can use this button. So this is a wireframe. This wireframe is open now, and there is this button. It closes open wireframes. If it's possible to close, this will close it. We close it. Now it's a solid object, and you can see here indicator that this closed, yes, and volume. For this objects there is no volume. It has just surface area. And here you can see it has surface area and it has volume and number of triangles, how many triangles, and number of vertices. For this also number of triangles and number of vertices. And if you want to see the labels, you can just make the labels visible. Okay. And when you work with wireframes, usually you need to you can use some other tools. So these tools are these normals. So normals, it helps to orient, to check if the created solid or some triangulation mesh is correct. So let's say we will show the normals of this object. So this is the normals of this object, and for this DTM normals of this object also you can see. So these normals are oriented down. So that means, yeah, these normals needs to be shifted, switched, because if you want to create a proper 3D DTM terrain model, so all normals need to look up. So this button will switch. Now these normals, yeah, they are oriented to up, so this is correct. This one is all normals oriented out, so this also correct. So why it's why we need to check these normals? Because when we do some Boolean operations, mesh Boolean operations, so depending on this normals direction, so some Boolean operation sometimes it will be incorrectly cut or incorrectly Booleaned. So that's why you need to, from time to time, need to check the orientation direction of the normals that created by user. So yeah, here also you can see right there. So all normals are oriented down. So actually for the proper DTM, they need to be oriented up. So we'll just switch it. Yeah. Okay. Once we created all these objects, now in order to not to lost our result, we need to save our objects, these objects. Dolon, we have our own format, so we can save all these layers independently, separately. Let's say these polylines, right? These polylines, just to check what polylines are they? You can make other layers invisible, and so show all. It will center this layers objects. So these polylines are the first polylines that we created. Now, so these polylines, oh yeah, this also are the polylines. So these are the points, and these are DTM, and etc. So now we can save all this data together as one file, or we can save all these layers independently, separately. So in order to save them separately, we can directly from these tools, from this, using these tools, we can save, let's say, these polylines. Saving polylines. So let me create here some folder, and inside this folder, polylines, polylines 1. So I've saved these polylines. Now these polylines are different polylines. Let's name it polylines 2, and these are points. So these points 3, or just points. And if you notice, so for points, extension is DPT. For polylines, extension was 3DPL. For mesh, these are mesh, generated mesh. Extension are DMesh, generated DTM. So we've created some of the layers separately. Later we'll load those layers. Or if you need all this data all together, you can just save all of them within one file, into one file. For this purpose, so we will use this button, save file, save to file, and from this form we'll tick this save send. It will automatically choose the file type. Okay, we'll click on it and name. Okay, let's name it all objects. File saved. So now we can clean up the screen. Okay, we've cleaned up, so nothing's here. Now, yeah, you can see, right, those files that we saved. So all objects, it contains all objects. Yeah, these are all objects. You can save all objects together, all, or let's open separately saved files. So these are generate DTM, these are mesh. So this our mesh that we saved separately, or these are our polylines. Polylines. Show all. Is it clear so far?
Yes, it is clear.
I think for today it's enough, right? I think it's a lot of information, and you need to digest all this information.
Okay, thank you.